Good evening, dear students. In this class, we will try to solve one classical problem in engineering mechanics or mechanics. Now, now the problem is that there is a wheel or some roller or a disc, that means basically a circular object which is placed on a horizontal plane, and it can roll over this plane or the surface. This is a special kind of rolling, that is called the pure roll, where the roll is taking place without any slip. That means when it is rolling, at the point of contact there will not be any slip. That means it requires that there should be enough friction that the roller or the disc will not slip at this point. So that means at this point of contact, the velocity of the roller will be same as the velocity of the plane. If the plane is static, then the velocity of the roller at this point or the velocity of the disk at this point will be zero. So that is called the instantaneous center of zero velocity in kinematics. So this is the classical problem of pure roll or roll without slip. Now we know this problem. Today's problem will be little uh, more difficult or little changed from the one that we see now. Here we have here we have one obstacle on the path like this. So here we see that the roller or the disc is there. On its path there is an obstacle. As it comes across this obstacle, and there is a force which is applied at the center of the roller or the disc, it is pulling the disc. The force that is required to make the roller or the disc coming over this, that means it should be the force should be such that it can pull it over this obstacle. So that is to be determined. That means what will be the minimum force that can pull it over this obstacle, that is to be determined. The obstacle dimension is given, that is height of the obstacle is h, and the radius of the disc is r, that is capital R and capital H, that is given. And for this problem, the force is a general force with an angle theta with the horizontal. That means it is above the horizontal and making an angle theta with the horizontal. So we have to determine F for uh, the condition that it can tip over at this point. Okay. Now, one thing that we have to understand, that for such problem, what is required, that when the roller moves freely without any obstacle, at all instants the point at which it touches the ground has the zero relative velocity of this with respect to the surface where it touches. Zero relative velocity means if the surface is static, then the point of contact on the roller will be also zero, having zero velocity. But here you see that at this point, at this instant, there are 2 points where it is touching the ground. So now as it tries to move further, that means before touching this point at the obstacle, when it was rolling, that means in this direction, in the direction from left to right, always the point of contact at the ground was having zero velocity. Now as it touches this point also, next instant onward, it will have at this point will at this point which will have zero velocity. That means at this point it will lose contact, or the contact at this point P, what was touched by the plane, will be lost. The contact will be lost because a very simple condition that for a rigid body, 2 points cannot have zero velocity when it is rotating. Two different points cannot have zero velocity when it is rotating. I have seen that many teachers are not mentioning this point, or many teachers are not mentioning this concept. Simply, it is told in many books also. I have seen that simply consider that this point is touching, and suddenly this point loses contact. Why it loses contact, it is never told. Uh, I have not seen such concepts mentioned in many books. Okay, so that is to be clearly understood, that why this point will lose contact. That is to be clearly understood, because this is a rigid body. 2 points cannot have zero velocity. That is the concept. So if it is having zero velocity, it cannot have zero velocity. If point A has zero velocity, P cannot have zero velocity. So simultaneously, both points cannot have zero velocity. So that is the key concept here in this problem and in all problems. So only one point can have zero velocity, and if it rolls further, so this forward point will have the zero velocity, and the point, the uh, that means the earlier point, or the uh, you should say that the previous point will lose contact in all situations. For example, it was, say for example, rolling. So if this point comes into contact, then this point will lose contact. That is quite clear. So for this, it is quite obvious. It is continuous, but here it is discontinuous. That is why there is a problem in concept. So it is to be remembered that when a forward point comes in contact, the previous point will lose contact. So this is discrete case and this is a continuous case. That is why that mismatch in concept, or that ambiguity in concept comes. Okay. Another concept that I have seen lacking in many textbooks also. You will see in engineering mechanics textbooks. I do not know why, unfortunately, that they do not mention that there is a friction at this point. Simply, they show that there is a contact normal reaction, and by showing that normal reaction, they solve whole problem without mentioning anything about the friction. But unfortunately, uh, that gives a wrong concept, because you see that without friction there cannot be roll without slip. Without friction there will be slip. So if it is a pure roll, that necessarily requires that there will be friction, there must be friction. Please, the books which are, I am requesting all the book writers, just please mention this. The students will be misguided. Please, that there will be friction. Without friction there cannot be roll without slip. I know that when you are solving by moment balance equation, that friction will be dropped, because that will not come into the picture, because you are taking moment about this equation. But that does not mean that the friction force is not there. Friction force is obviously there. Friction force is the key player here. So I am repeatedly telling, please do not do such things. Students are getting wrong concept. due to your writings. Okay, so that is a request from me, that students should not be misguided. So students, please try to understand that in many books you will see that there is no friction. Without friction they solve, but there will be friction. So now I go to the detail of the problem. Okay, so how many forces will be there if I try to draw the free body diagram? So the active forces, that is the weight, and the pull, that is this F, and this is, there will be a friction in the direction opposite to the direction of possible slip. So if this roller tries to roll in the clockwise direction, there will be a slip of this point A of the roller in the clockwise direction, that means tangential to the clockwise direction, and therefore the friction will be opposite to that direction, that is in this direction. So that should be simply understood, that without friction this problem does not have good, means right concept. So this friction will be there. Okay, next, normal reaction definitely is there. So there are four forces: W, Fr, N and F. Next, how many unknowns are there therefore here? This and this, three unknowns are there, and we know that three equations can be formed. What are the three equations? Summation fx is equal to 0, summation fy is equal to 0, and summation moment in the z direction to be 0, right? So no problem with that, therefore we can solve it. And we have seen, you can see that at this point P we have not shown any normal reaction, because when this force, that is the mean for the minimum force, at this point it tries to roll, the point P loses contact, therefore there will not be any contact reaction, so I have not shown it. Okay, so that should be clearly understood, the free body diagram. So let me write the free body diagram of the roller. Free body diagram of the roller. Okay, now let us try to understand what we want to do. Determination of the minimum value of F, which will cause the roller to lift over the obstacle at point A. That means here this force will cause it to tip over, that means it will roll over this, it will roll over this. Okay, next, here try to diagnose the problem. Only unknown is F here, that means if I want to understand the requirement from this problem, so it is asked that what is this force, so these are not asked here. So if we try to see from that point of view, the only unknown is F, but definitely these are also unknowns, right? But we are going to solve this only. So what should be the strategy? Let us try to see. Only unknown is F. For solving this unknown, we will use the moment of forces, moment balance equation about point A, moment of forces. So we will see the moment balance equation, that is summation moment, summation of all summation of moments of all forces about some point, any arbitrary point. So if it is 0, that means if it is not rotating at any point, I can take the moment center. That is the condition of statics. About point A, the corner of the obstacle, that is point A is the corner of the obstacle, so that in the moment equation, so that in the moment, if I take moment about this point, these two forces will not be appearing in the moment equation, because they will not give any moment, they will not produce any moment, therefore these two will vanish. Therefore I can solve this equation, I solve this unknown, because this is known. So these two forces will appear, but these two forces will vanish. Therefore I can solve from one equation one unknown. Okay, but that is why the authors of some book, they think that since means that force is not appearing, so as if they do not exist, they that does not exist. But it is not like that. Dear authors, please note that. Okay. Many students and teachers are misguided and due to this type of unthoughtful mm, uh, unthoughtful acts. Okay. Next is that so that in the moment equation, Fr and N, the friction force and the normal reaction, which are unknowns and yet to be solved, do not appear in the do not appear, and we can solve F easily. That means one equation, one unknown. From that point, we can solve it easily. So Fr and N will not appear, and we can solve the unknown F easily. Okay. Now let us try to see how to solve it. Okay. So you see that this angle, if I consider phi, this angle, if I consider phi, then we can write that. So this is phi, therefore this is also phi, and this is how much, this is, we can determine from Pythagoras theorem. So if I uh, give names, so O, say for example this is say E, so OE is equal to R minus H, OA is equal to R, therefore EA is equal to R square minus R minus H square, therefore that is equal to, if I solve, it will be 2RH minus H square. Okay. Next, therefore I can write that this is, if this is phi, then cos phi is equal to this this divided by this. So cos phi is equal to this one, that is EA divided by OA, that is root over 2RH minus H square divided by R. And what is sin phi? Sin phi is equal to, sin phi is equal to this divided by this. So sin phi is equal to OE divided by OA. OE divided by OA. So OE is equal to R minus H. O is equal to R minus H divided by R. Okay. Therefore, if we write the moment balance equation here, so what is that? Sum of moment in the z direction about point A. So that should be read as this: sum of moment of all forces about the z direction about point A is equal to 0. That means the minimum force that will be required. So if the force is just more than that, then it will tip over that point. So therefore, what is that? So you see that this force will be coming, so that will give you counterclockwise moment. So we will write that first. So W multiplied by, what is the distance? This distance, that is basically EA. So into EA, say length EA, we should write in terms of lengths. So okay, segment, right? Yeah. This is counterclockwise, and f cos theta into this distance, that is giving you clockwise moment, it will give you clockwise. So the green force component will give you clockwise moment. So minus f cos theta multiplied by this distance. What is that distance? That distance is OE. OE. And the component of f in the vertical direction, that is in this direction. So in this direction, that is minus, because that will also give you counterclockwise, clockwise moment about this point, clockwise moment. So f sine theta multiplied by this distance, what is that? EA. EA is equal to 0. Okay, f has two components, uh, horizontal and vertical, and w is only vertical. So this is the equation, and we know all this. Only f is unknown, so we can solve for f. What is that? We can solve for f. F is equal to, therefore, f multiplied by cos theta, and OE is equal to, here r minus h. So r minus h multiplied by cos theta, plus this will be plus. So EA, what is that? EA is this one, 2RH minus h square into sine theta. Sine theta is equal to W multiplied by EA. EA is this one, 2RH minus h square. Okay, so therefore the desired solution f is equal to W multiplied by 2RH minus h square divided by this one, r minus h cos theta plus 2RH minus h square sine theta. So this is our solution. This is the solution which we wanted to determine. Okay, now this problem has two more levels. Second level is that we have not yet determined these two values. The second level, in the second level, we will solve for the force equations and we will determine these two. And in the third level, we will determine what is the minimum value of the coefficient of friction at this point between the pair of surfaces, such that there will not be any slip. In this problem, what we have assumed that there is enough friction. So enough means how much? We have not yet discussed on that or thought on that. So we have just thought that it is enough, but there should be some value. There should be some limit of that coefficient of friction. So therefore, we have to determine how much coefficient of friction is required, the minimum value of coefficient of friction that should be there for no slip condition to be valid or no slip to be valid. So this is level 3. So in a future video we will see those levels. Thank you.